Last speaker for today is Andrej Shadura from Collabora, and he's talking about building an entire Debian derivative from Git. We look forward to listening to you.
Hi, thank you. So this will be the revision number 2 of this talk. I presented the first work-in-progress version at Mini DebConf in Hamburg. So let's start with what it's all about. The Debian derivative I'm talking about is Apertis. There were a couple of other talks mentioning this already. So Apertis is a Debian derivative tailored for car needs, basically. It was originally meant to be used in car navigation systems and all of those things. But since then, the focus has shifted to all sorts of electronic devices inside the car. And well, Apertis has quite a lot of infrastructure, which is in a way similar to Debian's, but slightly different. So we use at the core of infrastructure for Apertis. There's OpenBuild Service, OBS, developed by OpenSUSE originally. This is a huge web service which manages source packages, builds them, and basically provides all of the infrastructure needed to work with source and binary packages. We'll have a GitLab instance for code hosting and review, and image creator based on DebOS, which I talked about previously, and some other things like Jenkins, Lava for CI, and obviously bug tracker. So if we focus on OpenBuild Service, so OpenBuild Service is a great thing because it does, well, basically similar thing to sbuild. It allows us to build software packages in clean roots, where we pull all of the current versions of the packages each time from scratch. It has this primitive but very useful branching tool, so you can at any moment in time have a fork of this package in your private workspace or to some other project. You can work on it, test, build it without touching the rest of your distribution, and then submit a merge request, and it will be merged back. And it has some also quite primitive review tools, so the reviewer can have a look at the difference between packages, and there's no way, as in GitHub or GitLab, to comment on individual changes, but like there's a primitive commenting tool. And unfortunately, as I said, all of those things are quite primitive. So versioning system internally quite resembles a Git because it stores every file as a separate binary blob, which is referenced by its SHA-256 hash, or I think so. But on the outside, it quite resembles Subversion. Even the arrow prints and the progress and all of those things looks very much like SVN, and the command line tool also very much resembles it. Then the branching model also resembles SVN very much. So when you create a fork of the package, you actually just copy in the source package, we copy the project metadata and all of those things into your own project. The history is not preserved. So like if you look at, so this is the package-based files from Apertis, which is very much the same as in Debian, but with custom changes. So I've made a branch of this package from some development distribution, dev0, to pre-released branch, which is called pre, and I've done a couple of changes. So as you can see, the history seems to start at the first commit, which is the branching, but there's the button show all. So if we press show all, we expect to see more changes, which were predecessors of this one. So if we press it, we see exactly the same picture, because none of the history of the package before the branching is not preserved in this package. You need to find the original package where you branched from, or the project, and you can find the changes there. So basically, every time we create a new release, we'll lose all of the history of the package previously done. So you can see it in the changelog, but if you haven't stored the source package somewhere else in Git, it's a bit difficult to trace where the changes come from. well, but at least it has tools for computing diffs. Unfortunately, those tools are not very good because they are oriented mostly on RPM workflows, where there's a tarball and a spec file, which is a text file basically. So it's easy to compare. Or also OBS provides a spec-like workflow for Debian packages, where you basically just dump the contents of Debian directory next to the tarballs under different names like Debian dot control, Debian dot rules, and so on. So it compares them very well. But if you commit a changes file, for example, it shows you pretty much useless diff. Very similar happens to DSC files. They are diffed literally, basically hashes with hashes and all that. Sometimes it is able to unpack the Debian tarball and show you difference in files in there, but sometimes it doesn't do so. So it's very difficult to, well, basically the way OBS works prevents certain workflows from being useful. And we were looking for a replacement for this workflow, and because we already had some packages in Git, and we were building, using Jenkins, we were building source packages out of Git and we were putting them into OBS, but it was not enough, basically. And at some point we decided we just need to let OBS just build packages and provide everything but the versioning. So the versioning control of the source packages would be completely in GitLab, and OBS would do the rest. So OBS has its own mechanism to allow that, which is OBS source services, but unfortunately this mechanism is not very well documented, and the existing source service for Git, it's not really compatible with any of the sane Debian workflows. So, but the workflows themselves are not also quite diverse. So in Debian we've got lots of different incompatible, very often incompatible Git workflows. All of them are the correct ones, obviously. So yeah, every maintainer is free to use whatever they like, basically. And it's not mandated by the policy, even though Adam has recently started discussing a potential GR for mandating just one correct Debian workflow, but I don't think this is going to happen soon. So basically, that's one of the reasons why we can't just take existing Debian repositories in Apertis, because, as I said, workflows are all different. Repositories are not always consistent with the actual packages in Debian, because, well, one of the examples is Debian source local options file, which doesn't get into the source packages, but lots of people use it inside of the Git repository to, well, basically store the package options there. So there's, well, the Git maintained by Ian Jackson enforces consistent Git trees, and it's a good thing, even though I don't exactly agree with all of the design decisions, but it's a great thing. It produces consistent trees which have everything which you find in the Debian source package. But unfortunately, it's used by a minority of people, and so if we just try to use the Git clone, for example, to get Git history for Debian package, we would basically be creating unique Git repositories each time, and it's not very useful. And then, well, some people might still use Mercurial, Bazaar, and other version control systems hosted outside of the Debian infrastructure. They probably don't do so, but there's still possibility for this. And then in the process, as I said, we've already used Git for some workflows. It was basically a Deb14 style model with some minor differences, because there were some packages for which we were also upstream. So for those packages, there was a bit of a we didn't follow the package, Git build package or Deb14 workflow exactly. There were like basically double tags for upstream and non-upstream releases, but not very important. But the thing is, it was only for a bunch of packages we were upstream, or for packages we really cared about, like systemd or Armor. So for those who don't know what deb14 is, it's a proposal on what we want to put into branches, into Git branches when we maintain Debian packaging in Git, proposed by Raphael 5 years ago, and it's basically the same as what Git build package already provides, basically, which is patches unapplied, separate branch. I'll show it on the next picture, and it just defines how we name branches, tags, and other things. And unfortunately, it's not used as widely as I wish it would be. So this is more or less how it looks like. There's a number of upstream branches where we have unpacked upstream source with tags corresponding to the upstream releases. And there's a Debian master branch, or multiple Debian / something branches, like Debian master branch, Debian experimental, and so on, where we maintain upstream source plus the Debian directory with patches not applied to the source. So we adapted deb14 for Apertis in a pretty much straightforward way to accommodate the fact that we want to pull updates from Debian easily. So we still have the upstream. Well, actually, it's not upstream latest anymore. In the latest revision, we just decided to abandon upstream latest and have branches per release. So there's upstream buster branch, Debian buster branch, on which there are upstream sources plus the Debian packaging. And there's Apertis / release branch, on which there are differences between Debian packaging and Apertis packaging. So there's, unfortunately, there are some things which we had to change in that. I will talk about this later, because we use GitLab CI to build source packages from Git. So, but still, there's one important bit missing. We want to be able to reuse tarballs which are already in Debian. And as you can see in this, on this graph, there is nothing which would guarantee that tarballs we upload to Apertis are bit-to-bit identical to those in Debian. So in Debian, there's basically a workflow based on pristine tar tool, which is a tool written by Joy Hess, which attempts to build a bit-to-bit identical tarball based on information stored in Git in the upstream branch and some binary delta. This tool, in the source, it ships a SUSE version of outdated version of bzip2. It also ships parts of a differently outdated, differently deprecated version of bzip2, and also ships a version of gzip based on zlib, which originates from NetBSD. And if you look at the man page of that version of gzip, it says this: it's a Frankenstein's compressor, and well, you're not supposed to use it unless you really know what you're doing. Right, so it's a very magical thing, pristine tar. It's not guaranteed to work, and often doesn't, even though it mostly works. But for some packages it breaks. It's very dependent on how tar works, and when there was a change in some logic inside of tar recently, lots of packages broke, like pristine tar broke for lots of packages. And also gzip makes the pristine tar's job even more difficult, because of the design of gzip, you cannot rely on it to reproducibly recreate the tarball, or not the tarball, but the compressed tarball. So gzip even less reproducible than other compressors. So after experimenting with pristine tar, we decided to go a slightly different way and use the Git LFS to store tarballs. So Git LFS is an extension for Git, which does a similar thing to pristine tar, but in a completely different way. So when you commit a binary file to Git with Git LFS, the file itself doesn't get stored in the normal Git storage, but it gets stored in a completely separate blob repository inside of .git. There is no delta algorithms or any deduplication, anything applied to it. It's just stored as it is. What gets committed to the actual Git tree is a small metadata file which has the hash of the file, so that it can be found in this LFS repository. And when you push to the upstream repo, those files, they get transferred in a separate side channel, basically. And if the server, suppose they get stored there. If they don't, the push fails. And when you check out a repository where a commit of a repository where Git LFS is used, Git filters are used to recreate the file in place of the metadata file. So if we use this instead of pristine tar, we don't need to fight with compressors anymore because we just store file as it is. It's supported by GitLab, which we already use in Apertis and which is also used in Debian, Salsa. The protocol is really simple, and it can be easily re-implemented in case if upstream, for example, dies. I started actually implementing this protocol in Python, but just for fun. Really simple, just a lot of work to complete it and to comply with the specification, but it's not very difficult. Just have a fun time. So I've written a tool which is called Pristine LFS, which has exactly the same interface as Pristine tar. It's written in Python and not in Perl because I prefer Python to Perl. Underneath it, at the moment, uses the Go implementation of Pristine of Git LFS. If and when I complete this re-implementation of LFS in Python, I probably will switch to it. But at the moment, that's the easiest way. It doesn't support a few options of pristine tar which are pointless in case of LFS, like generate a delta file and so on. And I consider it currently a working prototype because we use it, but there is still potential for bugs in there, and some things are probably not implemented fully correctly. So this is what happens when you store a tarball in a repository using Pristine LFS. It creates a branch called Pristine LFS, and on that branch it commits two files basically each time. So one file is Git attributes, where it configures the filters and diffs and other bits to make Git LFS work with the file, and it commits the metadata file, a so-called Git LFS pointer file, which specifies what is the hash of the file, what's the size. There's one downside to this workflow, because if you have, like, let's say 24 of tarballs on Pristine LFS branch, when you check out this branch, if the objects have not previously been downloaded to your local repository, all of the tarballs will be downloaded at that very moment. So Pristine LFS works this around by, well, since it works exactly the same as Pristine tar, it only downloads the file which you specifically request. It doesn't download all of the objects by default. But if you go and check out the branch manually, you will get all of the tarballs, basically. I had to do this compromise because otherwise it would be very difficult to track what tarballs we already have there and which we don't. And also, potentially, some Git LFS garbage collection might remove old blobs at some point, so it was the easiest way. Just don't check out this branch manually, usually. That's the workaround. So this is how Dash repository looks in Apertis. So we have a separate branch with no roots called Pristine LFS, with the data for the tarball for Dash, and there's upstream branch, Debian Buster, and Apertis pre, where there's well, there's no difference basically between the Debian branch and the Apertis branch, except of one file, which is GitLab CI configuration. Because at the moment there's no way to tell GitLab that we want to run CI on this branch without the GitLab CI file. With base files it's slightly different. Base files is a native package, so there's no upstream branch. And well, it branches out like that because we're still using the previous version of base files, not one we have in Buster. So there's a bit of diversion and it hasn't been merged yet. There's also we've got also a package called tar-gplv2 because unfortunately we cannot ship gplv3 packages in the target images, which get flashed into the devices in the cars because unfortunately car industry is very sensitive about gplv3 and they don't want it. Basically, if we put gplv3 there, they just won't use our distribution basically. So in this case, it's a bit more difficult, more complicated. As you can see, there's upstream branch, Apertis branch, multiple commits, and there are two different tarballs. The original tar 1.16.1 and the 1.17 with renamed package. Package has been renamed, the source one. So the pipeline, which is the CI pipeline, which is defined elsewhere and includes in every package in this GitLab CI file, in this file, basically, this pipeline, what it does, when we push a tag to repository, it recreates the source package using the Apertis Git branch and the tarball, which is stored in Git LFS on the pristine LFS branch. It creates this source package and commits it to snapshots branch of the project on OBS. During this process, we also download all of the build dependencies and install them in the root because some of the packages, usually, very often, you can trick the package build package to create a source package without running the clean target, and in that case, you don't need build dependencies at this step if you create just the source package. But some packages don't like this thing, and you really need to run the clean target, and for that you probably will need the build dependencies. So it takes it takes much longer, and basically it's more resource intensive. Yeah, but we know that basically all packages can be built this way. Right. So and this enables new, better workflows. So we can easily pull updates from Debian. There's a CI job which runs each night, which creates, which updates the Debian Buster branch from Buster and puts new versions of packages from Debian there. It attempts to automatically merge the Debian branch with the Apertis branch, and at the moment it can only solve the merge conflicts which happen in changelog. So it is able to sort. It uses the package merge changelog tool, so it can basically sort and merge the entries. But anything else, if any other merge conflict happen, at the moment it doesn't attempt to do anything with that. It just bails out. But if it succeeds, it submits a merge request. So after a review by a human, the updates can be automatically pushed into Apertis. And finally, we can use git blame to sensibly find out why changes were done in packages and who did them and for what purpose. Because previously, it was very difficult. There was basically, sometimes people were forgetting to make a proper changelog entry. And even with the changelog entry, it still doesn't give you a full diff between versions because all the package versions were lost, basically. So this is a massive improvement compared to what we had before. So this is all still work in progress. As we speak, packages are being imported into Git, and there is still some issues with the tools. As I said, packages need build dependencies to build source packages, and installing them is expensive. And maybe we can work this around to stop doing this for most packages except packages which you really need it, but it's more difficult and needs more testing. As I said, GitLab cannot build things if it doesn't have a specific file in a specific location in a specific branch. There's an upstream bug at GitLab where people propose patches and basically ask to solve this, but the upstream still, well, no one managed to convince them about how exactly this needs to be done. There's a feature in GitLab called auto-DevOps, which runs a fixed pipeline on all basic repositories you have in GitLab, but unfortunately, it cannot change this pipeline, so we can't use it. It runs fixed a set of commands, and well, you need to patch GitLab basically if you want to change it. There's no way to change it per project or per group. Right, so Debian can also benefit from this work. When I presented this talk previously, I had this feeling that there's no way we can move all the Debian to Git. But just as I said that, there were people who commented on this, oh, that's actually not true. We can probably do this. We just need to be a bit more pushy. And it's actually now work in progress, Sean and Ian from the Git team. They are working on a solution to allow pushing packages to Debian by pushing a tag and not using the Git. And if this work succeeds, we're going to have something like what we built in Apertis directly in Debian. But that work doesn't solve the issue with pristine tar, and I hope that LFS and pristine LFS might get some use in Debian, because we already have all of the necessary infrastructure. We've got Salsa, which supports LFS, and I actually use it on a couple of my packages already. It's not integrated with GitLab, with Git build package, but it's basically a simple matter of code. I've got a couple of wrapper scripts which we use in Apertis, and I'm probably going to integrate them into pristine LFS. Oh, there's one line missing on this slide. Like basically, there's a script to import packages from a DSC, tarballs from a DSC, and a script to automatically export currently tarball for the currently checked out version. So if you want to learn more about pristine LFS, I have recently moved it to Salsa. Previously it lived in Collabora GitLab. So I have it under my personal namespace. I tried to bike share the better name, just create a group for just this package, but nothing except package pristine LFS, which is just too specific. So if you have better ideas, contributions are welcome. The packaging is currently in the Debian group, and the package is in the new queue, so it's going to be in Debian real soon. And obviously, we welcome contributions and patches, documentation, all that stuff. So currently, one page needs a bit of love because it not exactly corresponds the source code. But well, it's still work in progress. So thank you for coming, and I would love to answer questions. If it's green, it's on.
One check. Testing.
Thank you. If you have a package which is not Debian native package and you have a local change in its source code, does it go to Debian patches? Or is it committed as a separate Git commit?
Well, the workflow we use, which is deb14, which is, as I said, based on, well, deb14 basically mandates the branch name, but the default Git build package workflow tells basically how things are committed. So the default of Git build package is that patches they live in Debian/patches, and they are not applied to the upstream source we have in Debian in the Debian branch. There's a different workflow, and for example, the Git trees, the Git produces when you run the Git push, it applies the patches in Debian patches to the upstream source and pushes that tree to the Git server. So we don't do that. I mean, that workflow has a benefit of you can actually see what upstream source with all patches gets compiled, and with what we have, you actually have to run quilt push, push -a to apply all the patches before you use it. But this one has a benefit is that you don't have to commit each change twice to Debian patches and to the upstream source, or the other way around. Some people, they just apply patches, but they don't keep them under Debian patches, and they have them generated when they build the package. So we don't do that. We just use the plain patches and applied workflow.
So when you have your local changes, you can see them in Git history and Git blame as a diff between diff null
diff
and
of
the
diffs,
patch.
yes.
Okay, thank you.
Hello. I have a question about pristine tar, because I have always heard the rumor that it breaks for many packages. I have touched more than 100 packages. Am I just lucky? Can you name one single package?
I think you are lucky, because when I did in the beginning of February, I did a test run. So I didn't mention this in the talk, but in Apertis we split Apertis in 3 components: target, development, SDK. Well, there's more, but like packages from Debian are in those 3. And the target is the most minimal thing, which is basically stuff which you get in the images on the devices. So there's things like, Dash and Linux kernel and other basic stuff. So I did a test import of just the target into Git. Just normal Git GBP import DSC without anything. And it broke for at least 5 packages or even more. And as more upstream switch, for example, to gzip, this number is likely to become higher. And even if it doesn't fail at import, very often the tarball which gets extracted from pristine tar is not the same tarball as you've committed. I've had this a couple of times that I imported myself a tarball, and when I extracted it, the checksum was different. So
I was probably lucky. I experienced the latter, but only if I configured a Git build package to not use Git to not use pristine tar. Otherwise, I think it's broken that if you say I don't use it and use it anyway, and then it's produce something else. But I was always lucky. But
I think
maybe
you were lucky.
Yeah, okay, that's nice. I'm happy about this.
More questions?
So, as for the pristine tar, since you already store all the things upstream Git history in your repo, why you still want to pristine tar?
Sorry, could you repeat?
I mean, why you still want to use pristine tar?
Well,
because you have
right.
already upstream tag or other things in your
right.
repo.
So for Apertis, the need is pretty much obvious that we have the Debian source package. Well, if we don't have any local changes, the Debian source package is basically bit-to-bit identical to what we have in Debian. Usually, not always, but like usually, at least the tarball is exactly the same. So the difference may be in the Debian tarball, if we use a slightly different version of debhelp or whatever, or not debhelp, but the package. But usually it's the same, exactly the same source package. And but even in Debian, it's very useful because sometimes you need the original tarball when you rebuild the package. And if we move completely to Git, for example, and somehow you recreate the tarball from, say, Git, without having the binary delta in case of pristine tar, or like the original tarball in case of anything else, it may happen that you build the package against the original or the different original tarball, and you, for example, upload it with the tarball and it gets rejected because the checksum is different. It just lots of inconvenience when you have this probability of original tarball having different checksum. Even if I can't name it right now, but like I've had those situations very often when Oh yeah, in Apertis, for example, we use repre-pro to maintain the repositories. And it happens very often that we create a new release and packages which we maintained in Git. So we create a new release, we create new apt repo, we create new set of Jenkins jobs which build source packages from Git. In the moment when we branch, all of the Jenkins jobs, they start running because they're newly created and Jenkins thinks, okay, we need to build things. They run on the very same source as in the previous release. They create source packages and commit them to OBS. OBS builds them and submits them to the apt repo. And all of the uploads get rejected because files with exactly the same names have been uploaded with different checksums. So all of the uploads get rejected and we have no packages where we are upstream. Or no systemd and Apalma, which we also keep in Git. And so it's even just for this purpose, it's more convenient to have files which are exactly the same as what we previously had. I hope it answers the question. I diverged a bit, but still digressed.
One more question about the same thing. When you have your local Debian patch and the upstream Debian package adds a new patch, do you have a merge conflict in Debian patches series and how it's resolved?
I think likely there will be conflict unless the patches. So sometimes people add patches in the middle of series. In that case, I guess there won't be any conflict. But if it's the last line, usually it creates a conflict with git merge. So currently we don't solve it. So there's a tool which we previously used for those purposes, which is called MOM. It's so originally developed by Ubuntu called Merge-O-Matic. We had a fork of it called Merge-O-Misc, which literally is for this purpose. So it was actually looking at the patch series and checking where they can be applied together, and it was sorting them and merging the series. So currently this still is work in progress. We don't do that, but there's a plan to port this code to the new workflow.
Okay, thanks.
More questions? Right, well, thank you very much for that talk.